All right, so we are going to finish inverses today. So the main thing you need to know about inverses is in this little block right here. Okay, those are your steps. Step 1, you really don't even need to do. It's mainly just understanding that f of x is the same thing as y. Then switch your x and y, solve for y. This is how you find an inverse. Okay. Now, some of this is good practice for transformations like we were doing. This first one, not so much because we graph lines how we graph lines, but after that, we're going to see a couple other ones. So down here, first thing we're going to do is just graph the equation given to us. First off, what would be the parent function in question 1? Linear. Good. We graph lines by starting at our y-intercept and counting using our slope of down 7 over 2. We're going to start with an easy one because we don't want to do anything too difficult on our first inverse function. We also have to be able to verify that two things are inverses, but we are going to talk about that next class. I found that if we do this in the same class, you get them mixed up. So, what is the domain and range of that line?
All real numbers.
All real numbers for both. Good. Negative infinity to infinity. Now, this little notation here, f to the negative 1, that's the inverse. To find your inverse, like it says in the steps above, you take the original equation, you switch the x and the y, and then you solve that equation that you now have for y. Keep in mind, when you see that, you literally just swap the x and the y. Don't take anything with it. You don't take the fraction in front. It doesn't matter about what that is. It stays where it goes. You just flip the x and the y. Now, how do I get y by itself? I add 3 to the other side first. Now, how do I get rid of the negative 7 over 2 in front of the y? Multiply both sides by negative 2 over 7, and I'm going to distribute it to this. So, distributing my negative 2 over 7 gives me negative 2 over 7x minus what? 6 over 7. You could, of course, graph that just like a normal line. You would start at your y-intercept of negative 6/7, and then from there count negative 2 and over 7. Now, it's a little bit non-specific to try to graph negative 6/7. The other way to graph the inverse is to take the points off of the original line and switch them as well. This is right now the point 0, negative 3. If I flipped the x and the y in that, it now becomes the point what? Negative 3, 0. Same thing for the other 2 points. This is the point 2, negative 10. If I flip that, it becomes negative 10, 2. And the third point that I had on my line was the point negative 2 up 4. If I flip that, it becomes 4, negative 2. So everything about inverses flips the x's and the y's. It flips the x's and the y's when you're solving. It flips the x's and the y's when you're graphing. It also flips the x's and the y's in the domain and range. Now on this one, it does not matter, but it helps you later on. The domain becomes the range, and the range becomes the domain. Everything x's and y's flips. All right, any questions on this first one? How to find the inverse, how to find the domain and range, how to find the graph. All right, let's try a different kind of equation then. On the next page, I now have a square root function. Now, if I approach this using my transformations method that we were talking today, the parent function of this is a square root function. The square root function has the point 0, 0, 1, 1, and 4, 2. What transformation is being done if there's a plus 3 under the square root? Left 3, which means I take each of my points and subtract 3 from my x's. Again, not that you necessarily have to use the table. I'm just showing you how to use it until it gets to the point where you can do some of them on your own and others of them, if they're more difficult, you'll need the table for. If I wrote my domain and range for this, where does this start on the left? Negative 3 and goes to infinity. Range 0 to infinity. Then we do the same process for finding our inverse. This one is interesting, and there's a reason we talk about it. If I was to find the inverse of this one, I would take my equation, I would switch my x and my y, and I would solve for y. How do I solve this equation for y? I first square both sides, which makes my left x squared equals y plus 3. Then I continue to solve. What do I get y? Y equals?
Negative 3 plus x squared.
Okay, or x squared minus 3 is good too. What is that kind of equation?
Quadratic.
It is a quadratic. Now don't draw this with me unless you have a pencil. Your quadratic would look like this. How is that the inverse of what we had to begin with? It's not, is the right answer, right? Here is the issue with this one. Square roots and squareds are inverses of each other, but only parts of them. Here's where this comes into play. Remember I told you what else switches?
Range, domain range.
Domain and range. Now, if I simply use that and write down the range as my domain and the domain as my range, let's look at what this tells me. The range makes sense, negative 3 up to infinity. Does that domain make sense with that quadratic? No, it does not. It says it goes from 0 to infinity, which means it only wants me to have what part of this quadratic? The right part.
Oh, that's so cool.
So, if you read your domain and range correctly, you will then see that these are inverses of each other. You should see that they reflect across the line y equals x from each other. If you drew this right down the middle, notice this line always goes through their intersection point, and they flip across that line from each other. The other way that you could have graphed that is to just take your original 3 points that we had on there and switch them. That would have given you the right part of the quadratic. Okay? Does that make sense to us? Our last 2 questions have something in particular going on with them, and it is this. If I was to graph this equation that you